When we think about space exploration, we often imagine planetary missions or exciting journeys to the moon. Another vital aspect of space technology is Earth observation to understand our very own planet. One of the most exciting innovations in Earth observation is the collaboration between NASA and ISRO, resulting in the NASA-ISRO Synthetic Aperture Radar or NISAR for humanity. This mission is designed for Earth observation to deliver a wide spectrum of societal applications across the globe.
NISAR is a historic collaboration between NASA and ISRO, Jet Propulsion Laboratory Pasadena and Space Applications Center Ahmedabad. Its primary objective is to observe and measure the causes and effects of changes occurring on Earth's surface. The mission's advanced radar payloads are central to its capabilities. Space Applications Center Ahmedabad has developed the crucial S-band synthetic aperture radar SAR and its processing software as well as various applications. This contribution will be instrumental for maximum utilization of the collected data and will directly benefit India's diverse application needs and scientific research.
NISAR mission is a shining example of what humanity can achieve when we work together. This collaboration between Indian and US space agencies will benefit not just our two nations, but will also give insights and solutions to many of our global challenges.
NISAR is the most advanced Earth observation satellite of its kind. It employs sophisticated synthetic aperture radar technology in two frequencies, with L-band provided by NASA and S-band developed by SAC ISRO.
They employ a technique called SWIP-SAR, which enables high-resolution wide-swath imaging to observe the Earth's surface in incredible details in all weather conditions, day and night.
L-band, due to its longer wavelength, enables penetration through reasonably dense vegetation and shallow subsurface, while S-band generally results in a stronger backscatter power for a given target. To tap this synergy, Indian subcontinent, most of Antarctica and parts of Greenland are being covered in L and S-band combination, while the rest of the global landmass is mostly imaged in the L-band, following a systematic observation calendar.
Each of the SAR system is equipped with various modes for different resolutions and polarizations. As NISAR travels in its polar orbit, it is operated at designated times to image the region of scientific interest.
NISAR is designed to address several key science questions related to changes taking place in the domains of ecosystems, cryosphere, solid earth, coastal and ocean sciences. Therefore, NISAR would map almost the entire landmass of the Earth within 12 days with a fixed orientation and precise orbit that helps to measure changes.
The total forest cover on Earth is around 4.06 billion hectares, which is approximately 31% of the global land area. In India, forest cover is around 81 million hectares, which is approximately 21.7% of India's land area. Effective monitoring of these vast ecosystems has always been a challenge.
Forests are a major component of the global carbon cycle, influencing the planet's climate and atmosphere. It acts as both carbon source as well as carbon sink. Accounting these carbon fluxes is crucial for effective climate change mitigations and management of forest resources.
However, there are large uncertainties associated with the estimation of carbon flux from forests, and these uncertainties are even larger over tropical forests. This is primarily due to the lack of suitable assessment mechanism for forest growth and disturbances and difficulty in ground-based biomass inventory in the tropics.
NISAR will provide effective tools to quantify these carbon fluxes through accurate estimation of forest biomass.
Globally, we have lost over 400 million hectares of forest land in just 3 decades. And it's not just deforestation, forest degradation or the thinning of biomass is a significant threat.
India, despite an overall increase in the forest cover in the last 2 decades, sees a worrying decrease in forest density due to thinning of forests, logging and shifting cultivation. With NISAR, we will track these forest disturbances precisely, whether it is disease, human activity, or a natural disaster like forest fire. ISRO will produce forest disturbance maps of India at 20-meter resolution annually, highlighting regions with at least 50% biomass loss.
Wetlands such as marshes, swamps, and mangroves are Earth's richest and complex ecosystems that play a vital role in conservation of biodiversity, supporting local livelihoods, carbon sequestration, and climate regulation. These sensitive ecosystems are being affected by increasing water pollution, deforestation, and several anthropogenic activities. We are losing them at an alarming rate.
So this is where NISAR will be immensely helpful. NISAR has ability to penetrate into moderate to dense vegetation. It also has sensitivity to flooded wetlands. So it will be able to bring out information regarding wetland flooding and carbon uptake in vegetation. Particularly in mangrove vegetation, where the complex root structure is hidden under the mangrove canopy, NISAR will be able to bring out information regarding the carbon potential of this ecosystem. As a step towards monitoring, ISRO will develop annual mangrove cover maps for the coast of India at 25-meter spatial resolution using NISAR data.
Agriculture is the backbone of India's economy and vital source of livelihood for a major portion of India's population.
For farmers, the biggest challenge is uncertainty. When will the rains come? How much water do their crops need? Are there pests silently damaging fields? If farmers are able to know the condition of crops, they can manage their fields more efficiently.
A major challenge in Indian agriculture is the absence of harmonized and real-time crop information. The dynamic nature of agricultural landscapes with varying planting and harvesting schedules across seasons and regions necessitates a continuous and timely understanding of actual cultivated land.
This is where NISAR steps in. ISRO will produce an active crop area map of India 3 times a year for the Kharif, Rabi and summer seasons to help the dynamic tracking of cultivated land extent.
This will significantly improve crop acreage and production estimates for government use. These products will also feed into decision support system called Krishi DSS to provide real-time advisories to the farmers on planting, irrigation and pest control.
NISAR will also help in assessing crop damage, ensuring transparent and fair compensation to farmers under crop insurance schemes.
Soil moisture is the essential variable that drives crop growth, supports agriculture and sustains entire ecosystems. It also regulates water flow in rivers and aquifers, making it absolutely critical for managing floods and droughts. Tracking soil moisture is essential for ensuring food security, water sustainability, and our resilience to climate extremes.
Soil moisture, the water in the soil, influence every farming decisions like when and how much to irrigate, when to sow or harvest, and how crops will respond to the upcoming extreme weather events.
Yet, availability of reliable and accurate soil moisture information at field level is still challenging. Traditional methods of soil moisture measurements are often localized, labor-intensive, and limited by weather, which often resulted in poor yield, even crop failure, and stress on water resources.
This is where NISAR will bring a breakthrough. Using advanced RNS band radar, NISAR will deliver operational field-scale soil moisture product every 6 days at 100-meter resolution. That would be the first of its kind in the world with regard to the level of details and frequency. NISAR high-resolution soil moisture product will support smarter irrigation, assessment of crop water requirement, better drought forecasting, real-time water wasting, and early warning systems.
Water, the lifeline of our ecosystems, civilizations, and Earth's climate itself. Fresh surface water sources like rivers, lakes, and ponds only constitute about 0.0069% of global water. Monitoring surface water extent, that refers to the areas covered by water bodies at any given time, is vital for assessing water availability and managing water resources and planning for droughts and floods.
Long-term changes in the surface water extent can indicate the impact of climate change on water bodies and ecosystems. These extends changes with weather, climate, and by human activities.
Traditional methods for monitoring water extent are inefficient and tedious, especially for expansive and scattered inundated regions.
A NISAR-derived surface water extent product at 20-meter resolution offers a near real-time comprehensive solution to not only manage its water resources, but also helps in monitoring the health and dynamics of aquatic ecosystems.
The cryosphere, Earth's frozen areas encompassing glaciers, ice sheets, snow, sea ice, and permafrost, plays a vital role in regulating the planet's temperature, supporting the global hydrological cycle, preserving freshwater resources, while sustaining a unique ecosystem.
The icy parts of our planet are undergoing rapid transformation. These incremental changes not only threaten the freshwater availability, but also contribute significantly to sea level rise, which is an existential threat to coastal communities worldwide.
Therefore, assessment of cryosphere adjustments is crucial for understanding the regional and global consequences of climate change.
NISAR's ability to penetrate surface and subsurface layers will offer critical insights into the current status and dynamics of mountain glaciers and polar ice sheets.
NISAR will track sea ice dynamics, along with providing advisory for safer ship navigation during Indian scientific expeditions to Antarctica.
NISAR will have focused observations of Himalayan cryosphere, which is often termed as the third pole due to its unique geography and largest concentration of ice outside the poles.
With NISAR, various cryospheric science products will be disseminated to research communities for analyzing and modeling the seasonal changes in snow, glacier, and permafrost region.
Overall, NISAR will deepen our understanding of cryospheric processes and its response to climate change.
The oceans are constantly in motion. Winds blow over the ocean, tides rise and fall, and the sea surface itself changes due to factors like temperature, current shift, and even seismic activities. Our coastlines are dynamic frontiers, critical economic zones, and home to vast populations. To monitor these complex coastal environments, especially in adverse weather, is extremely challenging.
One of the most pressing issues that we face today is the frequent attacks of the extreme weather events like tropical cyclones and extratropical hurricanes. These natural disasters bring destructions to millions of people living near the coastal areas around the global oceans. By precisely measuring the wind structure, NISAR will give us an accurate and high-resolution distribution of the surface winds. This will help in accurate prediction of cyclone and hurricane tracks, and further help in mitigating the losses from such extreme events.
Ocean currents are important because they influence climate patterns, marine ecosystems, and even global weather systems. NISAR can help to track the speed, direction, and movement of ocean currents and can provide vital data for climate change and weather predictions.
NISAR's high-resolution radars will help to identify eddies and fronts. This data will be vital to understand global transport of heat and salt and how ecosystems are being affected.
Not only that, from NISAR data, we can easily identify oil spills caused by the leakage in the marine vehicles and help to mitigate the biohazard.
It will also provide invaluable data on coastal erosion and can show how shorelines are changing over the period of time.
Natural hazards such as earthquakes, landslides, land subsidence are a major threat to human life and property. These events are results of geological processes happening deep inside the earth that cause subtle deformation on the earth's surface.
NISAR will provide systematic and periodic radar images of Earth's surface. By combining successive observations, NISAR can measure the deformations of the Earth's surface with a precision of a few millimeters.
NISAR is designed to provide radar interferograms at every 12 days, measuring subtle changes on the Earth's surface. This will open up great research opportunities, especially for geosciences and geohazards.
The movement of Earth's tectonic plates lead to buildup of strain along geological faults. Earthquakes are caused by the sudden release of this stored strain energy. NISAR will measure surface deformation caused by earthquakes, including the sudden movements before and after the event.
These measurements are crucial for identifying areas at risk of future earthquake. A major focus of NISAR is to look at the plate boundaries like the Himalayas, where the Indian and Eurasian plates meet.
NISAR can monitor surface deformation at volcanoes before, during and after the eruption, and thereby provides vital information for hazard assessment. NISAR will monitor India's lone active volcano, the Barren Island volcano, along with other volcanic systems in the Andaman-Sumatra arc.
India experiences thousands of landslides, especially in the Himalayas and Western Ghats region, with some of them resulting in large number of fatalities. NISAR will effectively monitor and track changes for future hazard mitigation plans. Similarly, subsidence or sinking of land, often due to groundwater extraction, is another concern for megacities like Delhi and Kolkata.
NISAR's observations are vital for tracking the vertical land motion along coastal cities to understand the inundation risks due to land subsidence and sea level rise.
NISAR will image global land and ice covered area every 12 days, collecting about 35 terabits of raw science data in L band and 8 terabits in S band every day.
This enormous data will be processed to level 0B radar raw signal data and different higher level data products such as level 1 in range Doppler coordinate system and level 2 in geocoded map coordinate systems. NISAR L and S band data of scientific interest to Indian community is processed and disseminated by Bhunidhi portal of ISRO. All the science products for operational use will also be hosted on Bhunidhi.
Both NASA and ISRO have deployed corner reflectors to monitor the calibration stability of the instrument and to calibrate the data products. Additionally, natural targets such as Amazon rainforest, which produce consistent backscatter signatures, have also been considered for image calibration.
In India, square trihedral corner reflectors are deployed in various places of Gujarat and near Hyderabad during the NISAR commissioning phase. It also has a pan-India calibration plan for subsequent science phase.
NISAR is not just about collecting data, it's about finding solutions. From water security to food security, from disaster management to climate action, NISAR will help us to address real-world challenges.
Ultimately, NISAR is more than just a space radar observatory. It's about gaining a deeper understanding of our changing planet and building a better world for humanity.
The societal benefits of NISAR will ensure greater safety and foster a deeper understanding of our planet. Its vital data will empower us to make informed decisions, protect communities, and build a safer, more resilient world for future generations.